Okay guys, have some free time, so I decided to show some stuff. So today let's be doing this thing, and you can see it is a nice base system for doing stuff like splashes. I call it a surface splash actually in the system. So the point is that you get this rigid body simulated thing cached out already and stuff, and you can use it for you can use this system to emit all kinds of debris, splashes, fume, dust, or anything like this. And it has some cool features like it is emitting exactly from the edge that the impact happens at. It is nicely controllable, shape-wise and so on. So that's how it's gonna be looking at the end. And just gonna delete my TP, start over. So I start with just cached Mass Effects, like baked down Mass Effect simulation that I did really quickly. Nothing special, just to have something to play with. And then I'm gonna create my TP. So it's a bit bugged out here with the icons, but doesn't really matter. So I'm gonna bring in the cache teapot first in the TP, because I want to give you this workflow with actually a particle as the rigid body, which is, I guess, important because the way I've been doing it is that I cache the rigid bodies first, again made in TP, and then I add all the secondary stuff later on top of that original cache. So I'm gonna call this first group emitter, and I'm gonna get this into TP with the object to particle. So generator object to particle, that guy, and I'm gonna send it to the emitter group, and there you go. So there is this white tick inside, which means the particle is in there. Now the next thing I'll do is to place some particles on its surface, and these are going to be kind of the start point of my setup. So seed, create, should be seed, and just have a black box for this actually. And you see it's just position born with surface, so emitter, particle shape. Just send the particle to the on input, so you can get a per shot. So let's see, you see I have already the particles on the surface, but I don't really have the then following. So to do this, I'm going to use referencing, and we are going to be doing quite a lot of this today. So this reference is going to create a link between the seed particles here and the emitter, which is important when you have many emitters, because then you can do this. You can get the seed particle, you can get p-attach, and you can get the reference, and then you can, I always kind of forget how these things get connected, and then you can make them follow. And if you have many emitters, each seed is going to follow exactly the emitter which created it. Okay, so this whole thing dots, and let's make the seeds darker, and I'll make this guy just a box. Okay, so that's good. So now I'm gonna name this seed follow. So now what I want to do is to kind of project these seeds on the ground where the thing is hitting. So let's see, this is gonna be called project, and the projected particles I'm gonna put to a new group, which is gonna be the actual one which we are gonna be throwing around, like that. So I just want to project them on the ground, and to do this I have the intersect node. I'm gonna take the seed group, I'm gonna take the ground, direction is gonna be down. And then I'm gonna wire something into the, I get the float and put it into the distance. Speed, but you know, speed is length, it's just distance. Then what I can do here is that I can define pretty much at what distance I'm gonna get the projection. So let's just create the particles at the projection. So position born. So every time I get a hit, I want to create a particle on the position. Pistol shot 1 per call to the active group. Now let's see. Yeah, let me fill their speed. So this is what we get, and if you see from the top view, I'm gonna pretty much have a projection of the teapot on the ground in a certain distance. So when I increase that distance, I can get a bigger projection, like let's say this is called distance. I get a projection from farther away. So these things I use, for example, when I emit fume, and when you want to emit from kind of like the thing getting closer to the ground and emitting the dust just from the wind that it creates. That's when you use like a bigger distance. But you can see clearer here it's just a projection of the teapot on the ground. So I'm gonna use not such a big one actually. Let's say I think 10 should be pretty much okay. So then the other problem is that when I want to shoot these guys out, I don't really want to do it from the entire projection. I want to do it from the leading edge. And this is first going to look better, and second, it's going to be avoiding any issues with like particles flying through the object from the inside, and it's also going to be much more efficient in, you're going to have much nicer result with much less particles. So to do this, actually there is a simple analytical way, and I'm just going to paint something for you here. So let's say this is the object, you know. So let's say this is the ground, and the particles are projected from the object on the ground like this. So let's say we get the velocity of these guys in this direction. So let's say we get that velocity and we put it on the position of the particle, and we also get an up vector, and we add these two vectors together. So we get this kind of a thing. This is the addition of the two vectors. So you see that if I cast a ray along this vector and it doesn't hit the mesh, then the particle is part of the leading edge. On the other side, if it does hit the mesh, then the particle is not part of the leading edge, it's somewhere on the underneath. And obviously if I multiply this z here, or actually the velocity, I can tweak the steepness. So the steeper it is, the narrower this thing is going to be. Okay, so let's realize this now. I'm going to call this leading edge. Now to do this I'll need to have a connection between the active group and the emitter. So to do this I'm going to do one more reference. So now I have a reference which points from the active to the seed, and I have a reference which points from the seed to the emitter, which means that if I do get a reference twice in a row, I'm gonna get all the way to the emitter from the active. So let's try this now. So I want the active group and get emitter, get reference. Once is gonna take me to the seed group, twice is going to take me to the emitter group. So I want, in this case, the velocity of the emitter. So I will get the particle data and I'll get its velocity. So that velocity I want to add to up vector. So to get an up vector, we can just get a 0.3. And this z value of the up vector I want to be able to control, and this is going to be kind of my narrowness. So again, the higher this is, the more narrow the leading edge is going to be. So connect this to z value, yeah, and then I just have to actually get the unit vector of the velocity, just because I don't want to get this in its entire range. And this guy is in a 0 to 1 range pretty much. That's what I presume it to be. So I want to have just the direction of this vector. I don't want to have the entire length. And it's very easy. This black box is just you see unit vector, unit v1. So then the next thing I'm gonna do is just to add these two vectors together. And again, it's a very simple thing, v1 plus v2, no big deal. So now this is that vector here. It's the velocity plus the up times something, x here is the narrowness. Okay, so then I want to shoot a ray from the particle in this direction of this vector towards that mesh. Let's do this now. So shooting a ray from the particle towards the mesh of the emitter in the direction of the thing that we just calculated. So I'm gonna put these guys down here to make it a bit clearer. Okay, and here distance is not gonna concern me at all, just gonna max it up. Okay, so then I'm gonna kill the particles that have that ray hitting the mesh. But an important thing is that I will need to do this only on particle age born, just because otherwise it's gonna look wrong, because obviously the object is gonna move. I only am considered with the state of things when the particle gets born. So let's have it like this. Okay, now let's see how it's gonna work. And if I go to the top, you're gonna see that instead of the whole projection here, I only have the arc at the front, as you can see here. So if that narrowness goes up, like if it becomes 2, if I recalculate, then you see that it becomes even less of the particles here. And if it becomes like 0.2, you see it becomes most of the shape. So that's really useful. And you see it's like simple enough to be able to implement. No big deal, like a few nodes. Okay, so then I have the leading edge already. So what I want to do is to shoot these particles out now. So let's first make them live a bit longer. Actually, don't want them to die at all, so I'm gonna max this out. We have a nice trail already, and then I want to give them some velocity. So the most intuitive thing is to just get the distance between the particle and the pivot of the emitter, and use this just to get an outward, like a radial outward from the emitter velocity. So let's say, so I have the active group. So since I want the distance to the emitter, I'm gonna again do this double referencing. Okay, so this is my emitter here already, so I want the distance between these. There you go. And then I want to give the particles velocity, but since it's only an impulse of velocity, like only a touch in the beginning, I don't want to override the velocity the whole time. I add the particle age born default setting. So here this is going to be the direction, and for the speed I'm actually going to connect the speed of the particles to the speed of the emitter. So particle data with velocity output again, and just multiply it by something. Like, let's say 0.5. So now if I look from the top view, you're going to see I have this kind of opening fan, which is good. But if I look from the side view, the Z doesn't really work well for me. And I found the easiest way to deal with this is to just only use this as an XY velocity. So I'm gonna call this velocity XY, and use something else for the Z velocity. Now there are two ways of doing this. I could either disconnect this guy here and multiply this direction so Z is 0, but the problem then is that I'm not gonna be able to use this variation angle, because if I put on top of the Z0 a variation angle, I'm still gonna introduce some Z into the whole thing. So what I prefer to do is to have another dynamic set, and in the new one I'm just gonna zero out the Z. So I'm gonna be able to use the variation, the direction variation in the velocity XY. So here I'm gonna just get the old velocity. I'm gonna send it to a 0.3. I'm gonna say multiply all the x and y by 1, then z by 0, and replace the existing velocity with this. Here, speed, yeah, speed gets overwritten here. Okay. So this should be 0z. And then I'm gonna add the z velocity separately. So paste the whole thing again. So the way I want to do it is that I want to make the z velocity dependent on the x and y ones, just because in this with that setup, then I will be able to drive the angle of the wave just here. And otherwise, if I make the velocity z just a number, then we'll have to change this guy every time if I want to keep the angle. Every time I change the x and y, I'm going to have to change this guy. It's much less convenient, so I'm just going to connect this guy to that, and in this case I'm going to have the z velocity the same as the x and y, which is going to give me like pretty much a 45-degree angle of the wave. And here I can just say add this time, because I want to add velocity, and I'm gonna keep the direction z up, the one that is default, and I'm gonna change the speed, like connect the speed here, and this is gonna be angle then. Okay, this is quite cool. Now if I go to the side view, see what happens. You can see I have the particles like in a 45-degree angle, pretty much emitting from the backside. This is nice. Now the problem is that while this thing is working, it is trailing the emitter, which is not what I want. I want it to go like in front of the emitter. And the easiest way to do that is just to add the velocity of the emitter to the active particles, and in that sense I'm gonna be just adding I'm going to be just creating velocities on these particles which are relative to the emitter, because its velocity is always going to get added. So I have just a black box for this, which is really simple. Velocity compensation, and it's made to be used as a node. I'm just going to work it a bit. So the active group is going to get the two references again. Because I want to connect it to the speed of the emitter, I'm going to get the velocity again. and just gonna add the velocity there, and everything is set to add it again. So in this, so here I'm just adding the velocity of the emitter to the velocity of the active. Let's see how this is going to work. And you see I have now this wave going in front of the emitter, which is what I want. And obviously it's time to put in the gravity and deflection. So this is going to be active group, and then I have the U deflector. All these things I just load from black boxes because, you know, this is basic stuff that I do all the time, and it's pretty simple. That's why I'm just loading black boxes. So the active group here, bit less bounce maybe with the auto variation, chaos and friction. So let's see, and this friction I usually have just in the black box because when I use shapes, then I put in some rotation friction on collision, so they don't end up, you know, spinning when they collide. So with each collision they lose some of their rotational momentum, but they're not going to be needing it in this case. So let's see here how it's going to work. Yeah, I think my gravity is like way too much. My initial test it was 50, I think. So let's see. Yeah, this is more like it. Now you see I have a problem with a lot of leaking, guys. This is just because I'm creating this stuff on the very surface of the deflector, which obviously can get tricky for it to detect. So what I'm gonna do is I'm gonna just lift the particles slightly up, and instead of creating them at the position of the hit of the intersection point, I'm just gonna add Z1 to that position. So I'm just gonna lift them very slightly, and this is gonna now make it easy for the deflector to work properly. So you see I have no leaks anymore. Now the other problem that I have is that my particles are live all the time, so I get too many collisions that I detect that are not really, you know, fruitful in any case. They kind of insignificant, but I still calculate all of them. So what I'm gonna do is that I'm gonna create another group which is gonna be called deactivated, and every time that a particle goes, a particle's velocity and at collision goes below a certain threshold, I'm gonna send the particle to that group. So velocity here at collision, if it is inside like 0 to 5, then I'm gonna send the particles to that deactivated group. And just gonna give it some color, the same one but muted down, and I'm gonna stop them. The velocity from here. So when they enter the group this time, not when they are born, because they come from another group, speed becomes 0. Okay, and this is going to be obviously deactivated. Let's now see how it's going to work. And you see that, you know, they go into the deactivate group. Looks nicer. So let's look at the teapot now. Let's have a general view. I don't want the seats to be visible anymore. You can just look at this stuff. So let's see. You see I get quite a nice wave. Of course, you know, now the problem is that all this stuff is quite straight, so I can just go in and I can break it up a little bit, put in some variation angle here, auto speed variation here, and there was this. I can't put angle variation, but I can put some speed variation again. So let's see now. But it's quite nice. And you see, it's a very nice system that you can use to create all of these kind of things. So the way I do these things is that I first get this base system working, and then I get different versions of that base system, and I tweak it a little. So with one version I get big debris, with another version I get smaller debris. I could get, like, let's say, a lot less of these particles, but trail smaller ones from them. So I'm gonna get a bit of a more spiky look, and then I'm gonna get another version with some tweaks, like make particles less bouncy, shorter lifespan, that I'm gonna use for film emission. And this stuff is really nice for film emission just because it is gonna emit only in front of the object, then the object is gonna collide. You're gonna get this nice, winding trail around the object. So with one base simulation you can end up having a lot of elements, which is the key to how nice effects done. So yeah, that was pretty much it for the day. I hope you guys liked it, and see you next time.